Hello and welcome back. Today we're going to do basics of angles, but we're going to start out with a little bit of a warm-up with measures of segments. Okay, so P to Q is 7 and P to R is 32. Find Q to R. So if P to Q is 7 and P to R, which is this whole thing, is 32, we need to find this in the middle. Okay, so the way that we do that is we say, all right, I know that I have 7 plus some number in the middle. We're going to call that guy x, and it's going to be equal to 32 in length. So then we're going to subtract our 7 to the other side to get x by itself, and now we're going to get that it is 25. Okay, and that x is really the length QR. So QR is 25. So each time I kind of like to erase and go back to the drawing board with this so I can write on top of it. You may not have that option if you're using a pen or whatever. So if you have QR is 58, that's this piece right here, and P to Q is 13, we want to know what the whole length is from P to R. So this is an easy one. We're saying that 13 plus 58 is equal to what? So it's equal to the whole thing. So you're just going to add that together, and that's going to tell you that P to R is 71. Okay, next one. PQ is this in the middle, so that's x minus 5. And then from Q to R is 2x minus 1. So now what we know is that P to R, this entire thing, is 21. We need to find x. So we're setting this up as one big long equation. So you're saying x minus 5 plus 2x minus 1 is equal to 21. So I'm going to put my variables together that match. So that's going to give me 3x. I'm going to put these together and I get negative 6 equals 21. So now we're going to isolate the variable, get x by itself. So to do that, we're going to add 6, and I get 3x equals 27, isolating our x by dividing by 3. So x then is equal to 9. Okay, this time it is just asking us for x, so we can tell it that x equals 9. Sometimes it's going to ask us to plug that value back in and solve for a length, which takes us to our next one. Okay, so the next one says QR is 6x plus 1. And PR, which is our entire distance, is 14x minus 13. And P to Q is 5x minus 2. So we need to solve for PR. We need to solve for the length of the entire thing. So here's what I know. I know that 5x minus 2 plus 6x plus 1 is going to equal the whole thing. So I took this piece and added it together to get the entire length of 14x minus 13. So now I'm going to solve. I'm going to put my variables together and I get 11x. I'm going to put my numbers together and get negative 1, then 14x minus 13. So from here, I'm going to move around my variables if possible. Well, it is possible. I'm going to move the 11x to the other side. In that same step, I'm going to go ahead and add 13 to get rid of it. So then what I have is 12 is equal to 3x. Okay, so then I solve that, dividing by 3, and I get that 4 is equal to x. Okay, well, this is not asking us to find what x is this time. It's asking us to find the length of PR. Well, P to R is 14x minus 13. So in place of that x, we're going to put 4. Okay, so then 14 times 4 is 56 minus 13, and 56 minus 13 is 43. Okay, so the whole length of PR is equal to 43. So hopefully that's a good reminder of what we've been doing. And now we can move into what we're starting on for the day, which is angles and the basics of angles. I don't know why my ink's not clearing. Guess I'll just erase that. Okay, so we've talked about lines, we've talked about planes, but we haven't talked about the angles themselves. So filling in the blanks for this, what is an angle? An angle consists of two different rays that have the same endpoint. Okay, it's where they're going to start. The rays are called the legs of the angle, and the initial point, the end point, is called the vertex. And that's going to be important because the vertex comes back all the time. Okay, examples. Name the side of the angle shown. So we're going to go down and take this to here and name that angle. The two sides that are shown is B to A, and that's a ray, and then B to C. So when we want to name the vertex of this, well, the vertex of this is B because that's what it shares right here. That's what both of the rays come off of. So when you're naming an angle, you want to use the symbol like the angle. So this angle, you can call it two things. Angle B, because of the vertex, or if you have multiple of them, because we'll have adjacent ones eventually that share one, you can call it angle A, B, C. Just make sure your vertex is what's in the middle. Okay? If there is more than one angle with the same vertex, then 3 letters must be used. And that's what I'm saying with this one is you can call it angle ABC because you said that the B was in the middle. That is its vertex. Okay, the last part here is how many angles are shown in the picture below. Well, the picture below that you should have looks like this. So I'll draw this in here if you want to just draw this into your notes. So you have A, B, C, and D. Okay, so how many are shown? 3 of them. So let's go through what the 3 of those are. The first one is A, B, C. The second one is C, B, D. And then maybe some of you saw this first. This outside angle is the other one, and that is angle A, B, D. Okay, so you have 3 different angles in that picture there. All right, now we're going to look at angle measure. So when you're measuring angles, you're going to use a tool that is called a protractor. So the units on these are called degrees, and degrees use that little symbol. Congruent angles have the same measure or degrees. Because congruent means the same, so it's going to have the same measure or the same number of degrees. When starting to the measure of an angle, we use a lowercase m. All right, so we want to find the measure of these. So you need to remember that here's where we're starting at. Here's the 0, and then it goes 10, 20, 30, 40, 50, 60, 70. Well, we're just a little bit past that 70, so we'll say that that's 71. So the measure of ABC is 71 degrees. Okay, so how come you don't use these top ones up here? Well, you don't use the top ones because you're not going backwards. It would be like if this went over here, we would still keep using the lower ones. So the numbers up top are as if you were doing an obtuse angle, which means bigger, which is what we're looking at in the second one. So in the second one, same sort of thing. We're going 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, or 100, 110, 120. Okay, so then we're almost to 130, but we're not quite to 130. So we're going all the way out to its degrees. And my estimate of this is that ABC is about 127 degrees. Okay, so I said obtuse angle earlier, so now we need to actually talk about what an obtuse angle is. So acute, obtuse, right, and straight are the different angles we're going to have. An acute one is less than 90 degrees, and what that looks like is a smaller angle. It's a little smashed one. Obtuse is greater than 90 degrees, and that's going to be a big open angle. A right angle is exactly 90 degrees. So that's going to look like this. It usually has a little box there. And a straight angle is exactly 80 or 180 degrees. So that's going to make a straight line. Okay, so then let's talk about what adjacent angles mean. Two rays that share a common leg and a vertex, but no inner common points. Okay, so let's take this example. You have A, B, C, and D. Okay, so the angle, so I'll do this in different colors so you can see it. This angle, angle ABC, is going to be adjacent to angle CBD. Okay, because they share this leg. The leg they share is right here, and they share that vertex also, but they don't have any inner points that share together with that. All right, and then to the angle addition postulate. So this is pretty much the same as our segment addition postulate. So what this means is if angle I'll write this out and then explain it to you. That's a B, not a 13. So here's our angle. We got adjacent angles here. A, B, C, and D. Okay, so let's say that this one is 40 and this one is 52. Man, my writing, not good. All right, so we're saying that if we want to find the entire angle, A to B to D, that's the whole big angle. What we're going to do is we're going to take this smaller angle, ABC, which is 40 degrees, and we're going to add to it CBD, which is 52 degrees, and that's going to give us our entire angle of A to B to D, which when you put those together, you get 92 degrees. Okay, so that's what our segment addition postulate looks like.